paper chromatography. So the technique is you draw it in pencil, not in ink, because ink is a mixture and could be separated, and it will separate in this technique, and therefore it will smear the chromatography paper. So you wanted to find out about something else, but instead your ink will be the one getting separated. On the other hand, you can also say that pencil, graphite essentially, is a pure substance, so you do not separate it further. Okay, so pencil will not separate out, but the ink is a mixture, it will separate out. So you spray with a locating agent. So the amino acid itself are colorless. Amino acid spots on the filter paper are colorless. So when you are colorless, how do you tell if they are separated but they are colorless? You can't see with your naked eye. Yeah? So because they are colorless, you need to make it visible to read. Okay, so you want it to be visible, and it will become colored actually. So this locating agent is called ninhydrin, and it will make ninhydrin. It will make the amino acid spots colored, like purple colored, dark purple colored, and it's very easy to read. Then you become like dots like this. Okay, you want the label as RF. So this is the distance there, and S travel that much. So from the baseline to the S there. So use your ruler, and okay, I don't have a ruler here. Well, actually, I do have a ruler here. So just based on this screen alone, I can't show the ruler to you, but what I have is 2.7. So just based on the scale of my PDF file on my screen here, and I get 2.7 over 3. So there's 2.7 cm, and there's 3.8 cm. If you are viewing this on a bigger screen, it will vary, just like it will vary when you view this on a paper. 0.71. Okay, but I mean, if you view this on a paper, then you use the scale on the paper and it would be perfectly correct. I guess 2.7, 3.8, simply because I'm viewing this on my screen and that's the reading that it gives me. Alright. Next bit, describe and explain why water can be separated by distillation. So it's saying that why can you separate it by distillation? How does distillation work? Include a description for distillation you may draw. Okay, so distillation is a separation technique. So it's a separation technique. I do believe that is what the topic is called in O-level. So I use separation technique based on differences in boiling point. So it involves boiling. You have to evaporate, you have to boil off the solvent. In this case, you have got water, you have got copper 2 sulfate. This is giant ionic structure. When you think about it, it's copper 2 plus SO4 2 minus. This is water. This is simple molecular. Okay, between these two, which one do you think has a higher boiling point? Water boils at 100 degrees Celsius. Giant ionic structure, before you even boil it, the melting point is already quite high because of the stronger ionic bond between the cation and the anion. Yeah. Okay. So what happened is, you can draw. My diagram is gonna be quite bad. I'm gonna try my best to draw like that. You would have to heat it. Okay. You will have to collect it. This is what distillation actually means. You would need a condenser because you are distilling out. So when you evaporate it, when you collect it, you need to cool it. If you don't cool it, you're not going to distill it out. You can collect the water. It's liquid. So this is water in, and then this is water out. What is this? This is a condenser. Why do we need a condenser? Because, well, you know, you are what am I going to do here? You need a thermometer. Careful. Where do we want the thermometer to be? We want the thermometer bulb. We want the thermometer bulb to be roughly there. So this is a thermometer. We are evaporating something. We are heating something so that it turns into a gas, and then you can cool it down and collect it. If I leave it open like this, it's gonna escape before you even cool down, yeah? So I need to close it up. So I will close it up like this. And then the thermometer, you should probably draw a bigger diagram. Actually, my diagram is quite bad, yeah? The thermometer is just at the junction where the condenser connects to it. Okay? And then you must close the end, because if you heat up aqueous copper 2 sulfate, and then you have water going up, then the water is going to escape as steam from there if you don't seal it. But because you seal it, it's going to go down there. This condenser will cool down the steam and then back into liquid water. So you can separate it out. You can separate the water out. Okay, it says why water can be separated. Oh, well, you know, in aqueous copper 2 sulfate, there is only solid CuSO4 dissolved in water. I already mentioned it above, so I'm just going to put it into sentence now. What happened is copper 2 sulfate has giant ionic structure. Therefore requires lots of energy, or large amount of energy, to break strong ionic bond between copper 2 plus and SO4 2 minus, whereas water has simple molecular structure. Therefore only need to break weak intermolecular forces between H2O molecules. Therefore H2O boils ahead, much ahead of copper 2 sulfate, which does not boil easily. Okay, copper 2 sulfate is a solid at room temperature and pressure. Water is a liquid at room temperature and pressure. So you can think about which one is going to boil first, just based on the structure and bonding, yeah? Anyway, next bit. Copper 2 oxide, you have excess of it, is a solid. This reaction makes it aqueous, liquid, aqueous. Separating something which is a solid from something which is aqueous solution or liquid is very much straightforward. It's just like separating sand and water, yeah? So question 3a, barium chloride is a soluble salt. So as you will have known, this is an aqueous solution. Well, I mean, you usually use it as an aqueous solution. It's actually a colorless soluble solution, and it's a test for sulfate. Okay, and you add it onto something that has sulfate, and then you give off this white precipitate. So that's quite common in paper 3. But here you want to specifically prepare it by mixing these two solutions. So this is a solution, and this is also a solution. You need to say they're soluble and soluble, and you want to get a pure, a dry sample. So there are two parts to it. You want it pure and you want it dry. Okay, so the reaction between them, so here they want you to describe, right? So when you think about the reaction between them, BaCl2 plus H2SO4 will give you BaSO4 plus HCl, perhaps? Yeah, it should be, I mean, by exchange of ions, I guess. As this precipitate out, there's going to be a solid. There's still aqueous. There's aqueous. And there's aqueous. The equation should be balanced, which means there's 2 HCl there, okay? So this is the only solid that will precipitate out, whereas the rest are all aqueous solution. They don't tell us what is in excess and what is not, but because this is a solid and the rest of them are aqueous, it's quite easy to separate out solid, right? Okay, so first of all, mix the BaCl2. So I can use formula because as long as you get the correct formula, there's no way they can penalize you. Unless you get the wrong formula, then they will penalize you, okay? If you're doing this all-level paper, you should be well equipped with standard formula, right? Like Ba2 plus, SO4 2 minus, Ba2 plus, Cl minus, okay? So you need to know the correct formula, yeah? Then filter off. So you can use filtration to separate solid from a solution, right? It doesn't mix in, okay? Then filter off the precipitate form. It's actually a white precipitate, as you will know it from your practical, obviously. Filter off the precipitate form. Because these are in aqueous solution, meaning to say these are soluble in water, right? Okay, so the reactants and also HCl needs to be washed off. Needs to be washed off from the precipitate. By distilled water, okay? There's a reason why you don't use the tap water, because the tap water contains certain minerals that might cause impurity in your precipitate. Yeah, okay. So you don't want to use tap water. You want distilled water, and then dry the what is this? Dry the. No, you need to allow it to dry. You need to allow the precipitate, or you can call it a residue, left on the filter paper you want to dry it, right? To dry by either you put it in between filter paper. That's the fast way, but the best way is actually by using oven, okay? Or you can drying them, meaning the precipitate you get in between filter paper, okay? Part A, it's a precipitation reaction. So this is a precipitate, it's a solid. You form it from a aqueous, which is soluble, and dilute hydrochloric acid, which of course is aqueous as well. So solution plus solution give you solid. All right. So this is the reaction, AgNO3. Well, actually, I write the Ionic equation because I can write Ionic equation. Aqueous plus Cl minus aqueous giving me AgCl. Solid. This is a classic precipitation reaction. It is not a redox, by the way. Ag plus 1. No change in oxidation number of the silver. No change in oxidation number of the chlorine. Okay. You want a pure, you want a dry. So you need to think about separation, and you need to think about drying as well, yeah? So what can you do? You can mix the two solutions together. Mix the two aqueous meaning both are soluble, of AgNO3. So it's silver 1, Ag plus NO3 minus, and HCl aqueous together, and solid AgCl will precipitate out, meaning to say the solid will come out, yeah, it will be formed. All right, and then you have to filter. You have to filter, basically using the filtration technique, yeah? Filter the precipitate. Filter the precipitate to collect the solid AgCl form. Then you gotta wash it because you have some aqueous silver nitrate and you have some aqueous HCl which are soluble in water, and this thing is insoluble in water, so I need to wash with not with your tap water, but with distilled water or deionized water to rid of excess, meaning to say to wash off the excess AgNO3 and HCl aqueous. So once you wash off, then whatever is collected on the filter paper is your residue. So now you need to dry the residue by placing in an oven. So the oven we're talking about is not your cooking oven, it's the kind of oven we have in the lab to dry solids specifically, assuming your stuff doesn't decompose. Of course, you can also leave it to dry by placing it, in a dry place to dry, okay? Or by drying in between filter paper. There's something that people can do if they are in a hurry. Just collect the residue which are on filter paper, put it in between another sheet of filter paper, and then you just squash them together. They will get rid of whatever water that may be present, yeah? Or you could just put it in an oven to dry it. And we don't want crystal, we just want sample. So I do not need crystallization. If they want crystals, then I need crystallization technique, yeah? And I knew they would ask Ionic equation, including stat symbols. So I already put it there. So I just need to write it down. So Ionic equation, basically you omit or you remove all the spectator ion, which are the Cl minus and the NO3 minus, okay, which will appear on both sides of the equation. The solid doesn't dissociate, so that's why we just keep the solid there, yeah. Type of reaction that requires light, okay. So we talk about photochemical reaction. Photosynthesis require light. Taking photo is to do with light. You need light to take a photo. Chemical, because it's a chemical reaction, okay? So it's a photochemical reaction. All right, you will have heard about this in some organic chemistry, because you're doing an O-level paper. You know about the alkane can react with halogen, with chlorine or bromine, if you are in a photochemical reaction. Okay, so the decomposition of silver chloride into silver plus chlorine, which exists as a chlorine gas at room temperature and pressure. You gotta balance every single equation you encounter. Some people really don't like the half. I don't see why. Half times 2 give you 1. One chlorine atom on the right, 1 chlorine atom on the left. Okay, so that is just the decomposition of it. If you really don't like it, multiply the whole thing by 2. You are going to get that. They are the same, really. The two equations are exactly the same. It's just a multiple. Okay,